notation. Let's get the definition, let's talk about examples, and then let's practice. Okay, so let's get the definition, and then you're going to organize three columns where we're going to put examples. Yes. And then it says, if you are discussing an interval that has no bound, you use either positive or negative infinity. This is one of the most important lessons. It's used the entire year, even through pre-calc. You've got to know how to write interval notation, and it's very simple if you visualize a number line. It's very simple if you can visualize a number line. All you're doing is translating what is shaded on the number line to shorthand notation. Have y'all ever heard of shorthand? Writing in shorthand? It's kind of antiquated. It's an outdated technique, but shorthand writers use symbols for words so that they can write a big, long speech, in short notation. Interval notation is like shorthand notation for when you need to shade on a number line. Okay? You use parentheses or brackets. You should already know that parentheses means not touching whatever number it's next to. It gets up to it, but it does not actually hit that number. And then brackets means it is touching that number. So let me give you some examples. We have 5 examples where we're going to write the set interval that we've been doing. We've been dealing with set notation. Now we're going to deal with interval notation. Then I'm going to show you what it looks like in interval notation and what it looks like on a graph, on a number line. So the first one looks like this. The way you read it is it's the set of numbers x such that, that's that vertical line. Then we have an inequality. When you're reading an inequality that is compound like that, you always read it from the middle where x is. You don't read it a is less than x. That doesn't make sense. You always read it from x. So let me start again. We have the set of numbers x such that, go to the middle, x has to be greater than a and at the same time less than b. Does that make sense? So it's got to be greater than a minimum number and larger or smaller than a maximum number. Here's what it looks like on a graph. It's very simple. If we had a, clearly a is the smaller number because it's on the left, and we had a b on the number line, so like -4 and 5, for example. The set of x that I'm talking about is where? In the middle. So it would be in here, right? And now notice what type of inequalities. Just the plain ones. What does it not have? It does not have the or equal to line, which means it does not actually equal those values, which means you're using parentheses. There's two ways to do this. You can do an exaggerated parenthesis, which I actually like for some people because then you are going to use parentheses when you write the interval notation. Or you can use open and closed circles. The only thing I don't like about open and closed circles is I've had people in the past tell me that that was open. Like they don't make their circle large and like whatever you're going to use, I don't care which one you use, I want you to exaggerate it. Okay, pretend like the font just went up like 12 points or something. Whatever you use, exaggerate it so that when I look at it, I know for a fact you either meant parentheses or an open circle. Here's what it would look like in interval notation. Now you might think that looks like a coordinate point. It does look like that, but if we're talking about a set of values, then that's how you know it's not a coordinate point. It's talking about like a shaded portion on the number line that would be from A to B, but not touching A or B, right? So this is how you represent this in interval notation. You use the min and the max, and it's going to be parentheses, okay? All right, let's change it up. What if it was the exact same concept, but one small adjustment? What changed? Now we have or equal to, which means instead of parentheses, we will use brackets or closed circles. So if you need to come over here to the brackets and the parentheses, you could put open circle, and here you can put closed circle if you plan to use those. You will probably see me use a mixture of both to try to accommodate everybody's way of noting it. So we would have our number line, it would be going from A to B, but instead of parentheses, I'm going to do exaggerated elbow brackets, right? And then I would shade in the middle. For the interval notation, it's as simple as this. When you're writing interval notation, the purpose of it is how many numbers, imagine these were numbers, don't let the A and the B throw you off. Just pretend like they're random numbers, say 0 to 4. I don't know. How many numbers are in between 0 to 4? So your mind might immediately think like 4, 3, but I'm looking for what?
Oh.
You got the decimals too, right? I don't remember what this theory is called, but if you have, I always demonstrate this every year to try to help people wrap their mind around math. If you have from 0 to 1, okay, 0 to 1, don't think ruler. Don't think of a ruler as I go further and further. I want you to go from like, oh, she's talking about a ruler, and then I want you to go into, oh no, she's talking about a deeper level, like more numbers. What is half? Stupid question is half, right? 0.5. What is halfway to half? A quarter. What is halfway to a quarter? You should notice that it's doing what? It's multiplying by 2 because it's getting smaller. The denominator is doubling. So what's half of 1/8? 1/16. What's half of 1/16? What's half of 1/32? 1/64. Can we keep going? Yeah. No matter what I say, what's half of this, you have an answer, right? Because all you're doing is doubling the denominator. So at any given point, am I going to say, hey, what's half? And you're going to say, there's not a number. Is that going to happen? No. You always have an answer. Which means, wrap your mind around this. Like, physically, on a ruler, we couldn't go any further. Your finger would no longer be able to identify half because now you've run out of room. Mathematically, could we keep going? Yes. So that means that from 0 to 1, there are infinite numbers. And you might think that's not possible. You said from 0 to 1. No, mathematically, there's infinite numbers in between. The same thing is true for here. In between any two given numbers, there's an infinite array of numbers. So the purpose of interval notation is, if I say to you, here's a math question, and the answer is all the numbers between, you cannot possibly list all of them. You would never be able to list all of them because there are infinite numbers. So enter interval notation where you're saying, hey, the answer is from here to here and every number that you can think of in between. And then you just write it as an interval, which is why it's called interval notation. You're saying run from this number to this number, and that's your interval. The difference here was that this was closed, right? And then this was open. That was the difference there. All right, so now let's mix it up a little. So look at this one. Going to erase where it says open right here because I'm fixing to use the word open in another context and I don't want it to confuse you. So this interval, this set, is the set of all numbers x such that x has to be greater than a, which means the minimum value is a and then it's counting up, right? So in terms of the number line, you would just have some value A, and it is everything higher than that. So you would show that it's bottoming out at A. That's where it's bottoming out, so either open circle or parentheses, and it's going up. And then you would shade the arrow to indicate keep going. Now, because it keeps going, what open bound, what open, this means it's without bound. It doesn't stop. It's not a closed interval. It keeps going. In terms of Buzz Lightyear, it's to infinity and not thinking. Okay. It keeps going. So right here, because it's going to the right, it's positive infinity. So the way you write the interval is you say, okay, it's starting at A, but parentheses, and it's going to infinity. Now this is called an open interval. It's not necessarily because of the parentheses, it's because it has no bound. It is open to that side of the number line. A closed interval is when there's a limitation. Can't go under this, can't go higher than this. That's a closed interval. Doesn't matter if it's parentheses or brackets. It's saying you got a min and a max. Here, you only have a min and then you keep going. So that's an open interval. You can have a mixture. Let's do this one. We're going to mix it up. So this time we have a min value, a max value, but we only actually include, which one of those? We only include the max value, right? Because that's the one that has the or equal to. So you got your min, you got your max. It is not going to include A. It will come to it very close, but it will not actually touch it. It will include B, and then it's everything in between. So if you were using circles, you would have an open on the left and a closed on the right.
So it can't be A, but it could be B.
Right. So if I said, is A in this interval? The answer is no. If I said, is B in this set? The answer is yes. Here's what it looks like in interval notation. It's as simple as from A to B, parentheses on A, bracket on B. The last one that I want to look at brings us back to some of that fancy notation. It's the set X such that X is an element of, which just means X is in the family of real numbers. Which means it's the entire number line. So visually, it's the whole thing. Like, to infinity and beyond, and also to negative infinity. So because it's going from negative to positive infinity, that is how you write it in interval notation. And you have to use parentheses. Can you put brackets on that? No, you cannot. put a bracket on infinity, it means that you are touching infinity. Infinity is not a number. Infinity is a direction of counting. Okay, it's not an actual number. You cannot reach infinity. It's just saying, hey, keep going. Or if it's negative, keep going that way. Okay, let's practice, and then I'll give you the homework, the practice assignment, and then we'll be done. Does it ring at 50 or 55? Oh, 11? Oh, good. Oh, wait. Was everybody good with this? Good? Okay. Let's practice 4 of them, and then I'll give you the assignment. Thank you. Yes, thank you so much. Okay. Here's your directions. So I'm going to create the same chart that we just came off of, and I'm going to fill in either the set notation, the interval, or the graph, and you have to fill in the others. Okay, so we need to label our chart. We've got set notation, we've got interval notation, and then we have the graph. Alright, so we got 1, 2, 3, 4 practice problems. Okay, so those are your problems. You need to write the other, way of expressing it. When you get to number 2, I'm not asking you to start labeling on a number line 1.7. You can just draw the number line and then make your tick mark 1.7. You don't have to like count it out, measure it.
When it comes to infinity, unlike the graph,
Yeah.
it's implied that there's a parenthesis on the other side.
Yeah.
Okay.
When you
I
shade the arrow,
yeah,
it's encompassing that. number 2 would be an open interval. So it's going to be like this.
Yeah, I have.
And it's going what direction? Yeah, so then you're going to shade. Yeah. So everyone should be done with number 1, right?
Yes.
Oh, you just, okay, never mind. Fine. I know you have a key. No, you're so funny. Did y'all get that? For the top one? Number 2 is not supposed to trick you. It's an open interval because it involves an infinity, which means you've got to decide what way is it shading. It might be easier for you to graph it first. And like I said, all I'm looking for is you to just put a 1.7 on the underline. It is closed on 1.7, but it's going left. So the correct way to read it is it's coming from negative infinity and it's stopping at 1.7. And so now that you visualize that, then you can say, okay, so it's the set of values x such that x is less than or equal to 1.7. And that would be the open interval. Here, we got closed, then open. You will notice that when it's a closed interval between 2 values, the inequality signs always face like that. Or you can say, I don't know how you want to think of facing, but they always do that. You don't flip them around when it's a completely bounded interval. They will face that way every time when there's a min and a max. This one is open, starting at 3, and then going to infinity. Get it? Your homework is in your textbook in those front pages that say just-in-time review. That's what the J stands for right there. It's just-in-time review number 6, and I want you to do 1 through 10. You could just add it to your notes if you wanted to. You don't have to create a separate homework sheet. I would just maybe continue my notes and say, here's the homework. So 1 through 10. It's going to be in the very, very, very front of your textbook. Those colored pages 4, chapter 1.
I'm sorry.
So it's page, yeah, it's like, it'll say just in time review 6.
So, we have to go on the line.
No, you have a vote now.
Oh, I don't have
Oh, you don't have it. Which one did you decide you wanted?
it. I want the hard.
The hardbound?
But all of my crap really so hard.
Madeline, you have one? Yeah.